Okay, so right now I'm going to walk you through the follow-up lesson that I planned. I, of course, will attach all of this to the Google document and email attachments to you all. However, I thought it's a lot of reading, so why not talk you through it? So the lesson plan that I planned is actually for a 2-hour class period. I know on Friday it was a 2-hour class period, so next class would probably be a 1-hour period, but this way the teacher would have an option of just splitting this lesson plan into 2 days. I just really wanted to include the savings extension activity that I added for the students that I met with on Friday, and kind of actually take away that extension plan and turn it actually into a presentation project that they will be doing later today. So to get started, I wanted to talk about the objective. The objective of this lesson would be to further develop the students' concept of compound interest and be able to calculate future account balances. Now, on Friday in my demo lesson, students investigated compound interest, and they actually discovered on their own a version of, or the actual compound interest formula. So what they discovered was this one that I'm trying to highlight, but A equals P1 plus R to the T power. They did not see anything that has to do with N, and N is something that will be introduced in the lesson that I will go over today. Here I have listed what the variables actually mean. Some new learning that they will learn and go over in this concept is students will learn that interest can actually be compounded multiple times per year. That's what N is. And they will be formally introduced into the formula that they discovered. That will validate their mathematical reasoning from the prior lesson. Later on in the second half of class, after break, students will begin a savings account analysis project where they research their own savings accounts and will ultimately present their findings to their classmates. So this is actually a different version of that extension packet that I gave them at the end of class. But so in retrospect, had I taught the demo class, I probably would have not given them the extension packet and would actually give that as a class activity like I'm doing in the lesson plan today. Okay, I have some other details, but when I'm talking through it, I'll try not to go over everything since you guys will all have a copy of this to read through if you want more details. So some of the materials I have are here. I know that they have laptops. They will also want poster paper. I will add that here. I forgot to add it right here, but they will need giant poster paper and some markers for the presentation. The warm-up activity has 3 parts. I noticed that the students don't really work with worksheets, so at the beginning of class, I'll have these problems kind of written on the board in different spots. We have Michael, who has $150 that he puts into a savings account. His bank provides an annual percentage yield of 2.2%. Charlotte has $120 with an interest rate of 2.75, and Diego has $100 with an interest rate of 3.2. I try to, whenever I do examples, use student names just to kind of, I don't know, get the students involved a little bit and invested. So what you see in italicized, those are actually the answers, so they won't see that. The question I'm going to pose to them is, assuming that they all put their money in at the same time, who has the most money in 1 year? What about 10 years, 50 years, and what does this tell you? So they're going to be calculating the different amounts of money that they're earning over the years. And even though Michael starts off with the most, in 50 years, they're going to see that actually Diego, who started with the least, has the most money. I'll give them about 5 minutes to work on that. If they need more time, obviously I will give them more time. Based on what I saw on Friday, it looks like they'll be able to quickly work through that. So after that, I will have 3 volunteer students come up to the board, go over the warm-up, show their work, and students, my guess based on Friday's assessment, just watching them work, is that they are going to use the exponential version to find out how much money each is going to have in 10 and 50 years. They could have made a table, but that would have been a lot of work. So I'm really going to highlight that later after the students present that. I'll give some time for the other students to ask questions. At this point, I'll probably be standing in the back of the classroom letting the students lead. And after all the questions are done, I will redirect the class and really emphasize, if it hasn't been emphasized already, that they actually used a formula without knowing it. And today we're going to be exploring this formula a little more. The big point I want to bring up is here. So we've been assuming that all of the interest is compounded once per year. But what happens if it's compounded more than once per year? What if it compounds twice a year? Quarterly, monthly, weekly, and daily. This is what we're going to be exploring today. So I'm going to then reintroduce n, the variable n, as number of times the amount is compounded per year. The students have been somewhat introduced to n. Before my demo lesson on Friday, I got to observe Joe Robinson's class, and before that, the students had been introduced to n as a number. So, going over that, I will write the formula on the board. So that formula being A equals P1 plus P times 1 plus R over N to T times N. And that formula is right here. So I will write this on the board and have them try to understand, why are we dividing by N? And why are we multiplying by N right here? Maybe I'll have a turn and talk discussion, but what I want them to realize is that we divide by N is because if we have an interest rate, it's being split up, it's dividing a number of times per year. And the time in the exponent has to be multiplied by how many times is it compounded per year. So we will take about 15 minutes discussing these notes, and I'm actually going to have them redo the warm-up question, given that Michael's bank compounds monthly, Charlotte's bank compounds quarterly, and Diego's bank compounds semi-annually. Do their answers change? They will reevaluate their answers for the warm-up with this new information. They can work independently on this, or they can work on groups if they have questions to see and validate their answers with each other. The teacher, I would then bring the class back to a whole class discussion and have partners share out their findings. The conclusion should be that N actually matters and that it would change their answers to the warm-up. So at this point, we've done notes, we've done a warm-up, we've discovered N, and I really want the students to practice. So I have a problem trail activity. Students, I don't know if they've done a problem trail before, so I will describe what that looks like. But basically before the class, the teacher should have hung up problems around the classroom. And this is what the problem trail activity looks like. I have a brief example. Each page I've actually made down here for the teacher to print out. But I have this workflow up here to describe how a problem trail works. So basically, a problem trail is kind of like a secret worksheet in that the students will be working on problems, but they're going to be getting up and moving. So I'm going to have 8, I know there's 6 here, but I'm going to have 8 problems hung up on the wall. All of the problems are connected to another. So we would have 2 to 3 students. Joe's class is 17, so I'd probably say, yeah, 2 to 3 students if it's 8 worksheets at each station. Once that student completes the problem, so say you're at here, you solve the problem, you ignore this top section here, and you find your answer. So 3x plus 5 equals 26. We figure out that x is 7. So we move on, we find the worksheet that says x equals 7. And that's the indicator that we need to go across the room to find this worksheet. Then you solve for this one and we figure out x equals 10. So if 2 to 3 students are starting at different problems, then everyone's going to be spread out. You should be working across the classroom, walking across the classroom to solve these problems, kind of just following the trail of problems. And as you can see, all the problems are connected. So no matter where you start, you're going to have the opportunity to do them all. That's a brief overview of what a problem trail is. You can read more about it. I typed a lot. What I want to make sure that the teacher does is that the questions here that I listed, I actually listed them in order, so when the teacher prints this out, they should make sure to tape up the problems not in order. So maybe do page 2 by the door, page 3 by the window, and so forth. So here are the questions in detail. I can scroll through that, or in fact, I can zoom out so you can see. There's 8 problems and they all lead to one another. The last question will lead to the first question up here. So that is the gist of a problem trail. Back to the lesson plan. I'm going to give students about 20 minutes to do that, but because I know that everyone works at their own pace, I will also have that article, How Teens Can Become Millionaires article, for them to read afterwards. I also put the break after this activity, so if they finish early, they can go get a drink of water or take time for themselves. Something that I want to emphasize what the teacher should be doing during the problem trail is that the teacher should be circulating. I personally, whenever I do this activity, I don't care how many students are at each station after the first problem. So round number 1, I say that 2 to 3 students have to start at a problem, no more than 3 students. But afterwards, it's kind of interesting to see the pace at which students are working, to see which students are working really quickly, which students maybe are stuck and working at a slower pace, or just need more time. Maybe they have questions, seeing how they collaborate with one another. Also, a big thing I've noticed is that if students are clustering at a problem, this could be an indicator to the teacher that a particular problem is challenging, and the students may need extra assistance there. So, I think 8 problems, 2 minutes, 2 to 3 minutes per problem would be sufficient for them. I have a 10-minute break or so here. Given that the 2-hour period is an 8 o'clock class, I said they just need to be back by 9. So after the break, the teacher would have a little review session, bring the class back together, and ask about the problem trail activity. Are there questions? What challenges did we have? What mistakes did we catch ourselves making? It's inevitable that mistakes were made, so I want there to be a space where we can discuss those mistakes and what we learned about them. That may be 5 minutes or so, and then after that, I would introduce the savings account analysis activity. So the general gist of this is, I believe you guys saw the extension activity that I made. I modified it a bit to have more freedom of choice for the students. I do agree that the students having the ability to choice makes them more engaged, more independent, and it's more realistic for research as well. So in this activity, students are going to be splitting up into 4 groups. With Joe's class size of 17, that's what I based this lesson plan off of, that would be 4 groups, which is important for me because at the end of the class, I want at least each group to present a 5-minute presentation. So the parameters are that students will choose 3 or more banks to compare. So at least 3 banks. And they will be researching these banks online with their laptops. In the previous activity extension I gave them, I actually did the research for them, kind of finding a website with information about banks. But in this modified activity, I think it would be more interesting for them to use their laptops and do their research on their own. They will need to look at all different factors: the interest rate, the number of times it's compounded, and also T. So T being what is the time frame they're looking at. I'm not setting any parameter except for the principal amount, because I do think it's important to have a principal amount, just to have some kind of standard within it. I did not set a time period. I want them to decide what their time period to be in order to make an argument for whatever they're trying to present. So do they want to save for 3 years? Do they want to save for 10 years, 50 years? It's totally up to them to make their own time frame. The teacher would then pass out poster paper and markers for them to use, and make sure that the students understand the presentation should be around 5 minutes. There's also a rubric that I made. So this is the basic description of the project. Let's investigate savings accounts and the directions. You can see there's not too many parameters except for the principal amount they're going to start with. Here's a list of banks that they can use, but they don't need to use. And here is the rubric. So I have the rubric based on, they will be graded based on their research, how well are they researching and getting all the information, the mathematical analysis, presentation, are all students presenting and using visuals and displaying their work in process on how they reach their conclusion. There does need to be a conclusion on which of the 3 banks they think is best for them. And a participation, did all students participate equally, or not equally, or did only a few students participate? So this is a basic rubric. Definitely open to modifying this a bit too if students think that something else should be considered. So just to know, I would not have given them the extension that I gave them on Friday. Instead, I would modify that for this. Some of the feedback I got when talking to the teachers on Friday was students at Beaver really like choice. So I'm hoping that this opportunity gives them a choice to choose what kind of banks, be able to go online and do their own research, give them more independence to make their argument in their presentation. So back to the lesson plan. I have them work by themselves. I'll of course be circulating, helping them, observing them, seeing, making sure that, kind of encouraging that they're on the right track, but leaving room to make mistakes. And at about the 30-minute mark, I'm going to leave 20 to 30 minutes for each group to present. So because there's 4 groups, that ideally would be 20 minutes, but of course I want to leave some buffer room just in case groups take more time. In general, after the students present and I give them feedback, I would like to close the class, probably just giving them feedback about how their presentations went, getting a sense of feedback from them. How did they like the presentation? Do they feel like they've learned? Usually, I like to end the class with some kind of assessment to see what their understanding is, but in this case, I think the presentations would be a good opportunity for basically a very long exit ticket. The teacher can do a quick fist to 5 to see how they like the activity and how well they understand the content, to see if the students' awareness, self-awareness of their own content knowledge and mastery is the same as what the teacher assessed as well, if that makes sense. So that would be my 2-hour class. And yeah, thank you for listening. And please let me know if you have any questions. Thank you.